Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how to avoid double counting hydrodynamic effects when you're using nonlinear Froude-Krylov forcing in ProteusDS Simulation Toolbox. So to explore this a little bit, I'm going to use a sample project with a 20 meter by 20 meter by 2 meter box barge that we've used in a number of other video tutorials. This square barge that I've got here is set up with the hydrodynamic database with incident wave, diffraction and radiation loads from the calculated by the Shipmo 3D toolset. I've got a little visualization model here where I put the same mesh that I used to calculate the hydrodynamics in here as well. So the visualization mesh feature is just purely for visualization. There's no forcing or anything like that, but it shows you what it's like. Now I made a copy of that rigid body model, and here's how I'm going to set up the nonlinear Froude-Krylov forcing. What I've done is I made a different named feature for the hydrodynamic database because we're going to start turning on and off different loading flags, and if you use the same named feature, it's going to use the same properties for both of them. We want to have a different feature for that. So if you right click on this and go to feature definition, you can see what I've done is I've turned off incident loading. So it's reading the same database file, but we're not gonna use the incident loading. So that's the wave excitation forcing from the undisturbed waves that are coming incident to the body here. And what that really means is the dynamic pressure field from the undisturbed waves, and what the forces are on the system from that. And the other thing that you want to do, you want to leave diffraction loading on. Yeah, it's still calculated from the assumed constant wetted hull area and radiation loading, but we don't have another way to manage the nonlinear effects from those. The restoring loading you also want to turn off. That's why it's set to 0 here. Ultimately, that is another set of forces calculated from the static pressure field around the body. So when you're doing nonlinear Froude-Krylov loading, you're taking care of the instantaneous forcing from the wetted hull area from the dynamic and static pressure field, from the undisturbed dynamic pressure field from waves in the dynamic simulation. So we're going to leave everything else alone here. We're using the resistance loading from the hydrodynamic database and so on. And when we go back to what I've done here is I've added a custom mesh feature to this now and loaded in the same hull OBJ file that I was using for visualization. Again, this is the same mesh that was used for calculating the hydrodynamics in the Shipmo 3D toolset. You could use a cuboid feature because it's just a box after all. It's kind of good practice, I think, to make sure you're using the same mesh, but I mean, you could play with this and use a different resolution if you really wanted to as well. So what you want to do is in this custom mesh, we want to make sure we've set hydroloading to 0 because we don't want it. This is the Morrison loading with drag and added mass effects from that mesh. We want to turn that off because we're already using the resistance loading from the hydrodynamic database. And this is the key one here, the hydrostatic Froude-Krylov loading. So what Proteus will do is at each instant in time, for any wetted panels that are below the water surface, it's going to be calculating the static and dynamic pressures on each of those faces and applying the forces to the rigid body overall through time. And a good reason to do this might be in extreme conditions when there's lots of changes in the wetted area of the hull through extreme waves or something really severe is happening. You might get a little bit of a better capture of the dynamic effects from that. Certainly there's advantages to using the incident loading directly and restoring loading. It's neither is always better than the other. There's reasons to use one over the other. But what I really wanted to highlight is how you avoid double counting of that. So again, in the custom mesh, you want to have hydrostatic Froude-Krylov on. Make sure you pay attention to how you're using the hydro loading, the drag loading. And then we go over to our hydrodynamic database here, and we want to have restoring loading off and incident loading off as well. So I'm going to run a real short simulation. I put both of these barges up in the air over the water just to let them plop down and fall in the water really quickly. And we'll get a little bit of a difference because the way that it's calculating the hydrostatics is different. they both plop down. There's a little bit of a difference, but they both settle pretty quickly. And one of them is calculating, this is the one with the nonlinear Froude-Krylov effects, and the other one is using the linear effects. So that's how you can set them up, and just be wary of double counting those hydrodynamic effects. All right, thanks for watching.